Hi, I am Shishuyen. I will present about Introduction and Thermodynamic Basics. What is thermodynamics? Thermodynamics is the branch of physics that deals with heat, energy, work, and temperature. It explains how energy is transferred within physical system and how it affects matter. In thermodynamics, there are two important laws which is the first law and the second law. So we go to the first law first. So the first law in thermodynamics states that energy cannot be created or destroyed, only transformed from one form to another form. So the equation for the first law is delta U equals to Q minus W, where the delta U is the change in internal energy, Q is the heat added to the system, and the W is the work done by the system. So we go to the second law, where the second law is also known as the entropy law. So it states that the total entropy of an isolated system will increase over time. Heat naturally flows from hot to cold objects, not the reverse, which is without the external work. So no heat engine can be 100% efficiency. How does thermodynamics apply in daily life? So in this slide, we have three examples. So the first example is the refrigerator. It used the second law to remove heat from inside and release it outside. So the temperature inside the refrigerator will always stay cool. The second example is the engine. So it applies the first law to convert fused chemical energy into mechanical work. And then the last example is sweating. So body will release heat through evaporation following the thermodynamic principle. So for sweating, it applies the first law of the thermodynamics. What is Brayton cycle? Brayton cycle describes the thermodynamic process in gas turbines, uses in jet engines and power plants. So it involves four stages, which are compressions, combustions, expansions, and exhaust. So we go to the first stage, which is the compression. So the air is compressed, which will increase the pressure and the temperature. The second stage, combustion, where the fuel is combusted, which will heat the high pressure air. The third stage, expansion, the hot gas expands through a turbine and it will doing work. The last stage, exhaust, the waste gases are released to the surrounding. So what is the role of Brayton cycle in thermodynamics? So it applies the first law which converts the chemical energy into work, and it also applies the second law where not all the heat becomes work.
So I am Chang Ming Wei. I will present about the theoretical Brayton cycle. So this is the whole cycle of the ideal Brayton cycle. And the first step to the second step, we will have the low temperature and low pressure ideal gas flow into the compressor and compress to high pressure. So this step is isentropic compression. In this step, our entropy will be constant. And from 2 to 3, we are going to provide the heat so that the temperature of the gas will increase in constant pressure. So this process is isobaric heat addition. From 3 to 4, we have the turbine. So our high temperature and high pressure ideal gas will become low pressure and high temperature. So this one is isentropic expansion, and the entropy will be same in this step. And 4 to 1 will be the isobaric heat rejection. The heat will flow out in this process so that the gas will be from high temperature to the low temperature, and the pressure will be constant in this step. So the formula in this cycle is, the first one is, this is the work in, because the compressor require the work to function. So the work in will be produce the work out, and the work in will be negative because it's the work required in this cycle. And the work out will be positive because it's the work produced by the cycle. So the net work will be work out plus work in. And between the step, we have the 1 to 2, the work in, rate of the work in equal to rate of the mass flow in this cycle times H1 minus H2. So since H1 is smaller than H2, then we will get the negative value. And the negative show that the work required in this cycle. So from 2 to 3, we will have the rate of the Q in equal to rate of the M times H2 minus H3. So this one will be negative because the heat is required. So third to fourth will be the rate of the work out equal to rate of the mass times H3 minus H4. So this one will be the positive value to show that this is the work released or the work produced in this cycle. And the final is 4 to 1 is rate of the Q out equal to M H4 minus H1. And this one also positive because it's the heat produced in this cycle. So the efficiency of the cycle can be calculated by net work divided by Q in. So net work can be equal to this work out plus work in over Q in. So we can substitute the formula from just now. You have the middle one, the formula, and we can cancel out the m so that we can get the final formula. And why we have the modulus? Because our Q in will be a negative value, and the modulus is used to cancel out the negative value. So this one is the PV diagram and TS diagram, which the 1, 2, 3, 4 will be same as the cycle just now we discussed. So 1, 2, 3, 4 for the PV diagram, the 1 to 2 is the work in, and the pressure will be increased when the constant entropy in this process. And 2 to 3 will be the Q in, and the temperature of the gas will be increased in constant pressure. And 3 to 4 will be the work produced by the cycle in constant entropy. So the pressure will be decreased from high to low. And the final step will be 4 to 1. The heat will flow out from the cycle in constant pressure. So the TS diagram is just same. 1 to 2, the S is constant and the pressure is increased, temperature is increased. And 2 to 3, we heating up our gas, so in same pressure. So the temperature will increase rapidly. And 3 to 4 is the work out by this cycle in constant S. And 4 to 1 will be heat release in constant pressure. So this is the assumption of the ideal Brayton cycle. We have four. The first one is ideal gas. We assume that A is behave like ideal gas, which the specific heat capacity at constant pressure and constant volume are constant. And the second one is internally reversible process. We assume that all of the process are reversible, which means we have no friction or other irreversibility. And the third one is constant pressure, heat addition and rejection, which we assume the pressure is constant at the process 2 to 3 and 4 to 1. And the last one is isentropic compression and expansion occur. So we assume that no heat transfer and the entropy stay constant at the process. So in reality, these four assumption will not be occur, so that our efficiency of the cycle will be lower than the ideal lah.
My name is Nur Ain and I will explain about the example which is jet engine and gas turbine in power plants. Before we start, I would like to explain a little bit about these two things as an overview. Uh, even even though jet engine and gas turbine is operating based on Brayton cycle, but they serve a different purpose. In jet engine, the main goal is to produce thrust, while in gas turbine in power plant, the main goal is to produce electricity. As I mentioned earlier, the jet engine operates based on Brayton cycle. It begins with air from atmosphere being drawn into the engine, where it will be compressed by compressor. This compression significantly will increase the pressure and temperature of the gas. Then the high pressure of the gas will enter the combustion chamber where fuel is injected. Combustion takes place at constant temperature. Hence, the temperature and energy of the gases will increase rapidly. These hot and high pressure gases will expand through a turbine to produce mechanical energy. The remaining high speed exhaust gases will expand through a nozzle to produce thrust that will propel the aircraft forward. All of these processes are continuous. Here I will explain about the comparison between ideal jet engine versus real jet engine. In ideal jet engine, both of compression and expansion are assumed to be reversible and isentropic. That's meaning there is no friction or heat loss. But in real jet engine, these processes are irreversible due to effect of friction, turbulence, and thermal losses. In combustion, ideal jet engine has a perfect and instantaneous combustion that will ensure the maximum energy will be released. But in real jet engine, combustion is less efficient with loss of pressure and sometimes incomplete fuel burning, which will reduce performance. This will lead a type of efficiency where in ideal jet engine efficiency is high, but in real jet engine the efficiency is low. Lastly, the component in ideal jet engine is idealized, with no mechanical losses and no material limits. But in contrast, real jet engine must be built with material that can withstand extreme temperature and pressure. Gas turbine of power plant is operated based on Brayton cycle too, as I mentioned earlier. It is began with air being drawn into a system and compressed to the high pressure. This compressed air then will mix with fuel and will burn in combustion chamber to produce gases with high pressure and temperature. These hot gases expand through a gas turbine, causing it to spin and drive generator to produce electricity. While the gas turbine generates power, it is also produces a hot exhaust gas. To avoid this energy to go to waste, many power plants use a combined cycle system where the hot exhaust is fed into a heat recovery steam generator. This will feed steam to power a steam turbine that operates based on Rankine cycle. Rankine cycle generates additional electricity and improve efficiency. And lastly, this is the examples of the jet engine and gas turbine in power plants, where the examples of the jet engine is Rolls-Royce Street 1000 and the examples of the gas turbine in power plants is Siemens SGT 800.
Hello, my name is Hazim Daniel. Now for number 4, I want to talk about real-life application aircraft propulsion. What is aircraft propulsion? Now I will explain the meaning. Aircraft propulsion is the system that used to generate thrust which move an aircraft forward through the air. This thrust will overcome air resistance and enable lift-generating wings. Modern aircraft use ideal jet engines that operate based on Brayton cycle. Now I will go through the part of how Brayton cycle powers aircraft. For the first part, I will go to the compression part, which is isentropic. Air is taken in through the engine intake and compressed by a compressor that will increase the temperature and pressure of the air. After that, we will go for the combustion, which is isobaric constant pressure. Fuel is injected into the high pressure air and burned in combustion chamber. This creates hot and high energy gas while the pressure is constant. For the next part, will expansion in isotropic hot gases expand through a turbine that will drive a compressor and generate mechanical work. The remaining gases continue to expand through a nozzle to produce thrust. And the last one is exhaust, where high velocity gases exit the nozzle and propel the aircraft forward. In Brayton cycle, there are many types of jet engine. Now, I will explain one by one the type of engine in Brayton cycle. For the first one is turbojet. How it works? All air passes through the core to produce high-speed exhaust. Example use is fighter jet. Then we have turbofan. It will work by passes some air around the core using large fan, so it is more efficient and quieter. Example use is commercial airline. For the next part is turbo drop. How it works is use gas turbine to drive a propeller. As example use is regional aircraft. And the last one is turbo shaft. How it works is it will transfer engine power to a shaft, not thrust, that used in helicopter. Example use is helicopter or naval ship.
The importance of the theory of the thermodynamics in the applications have three, which is the first one is height power to weight ratio. Engines can produce a large number of power relative to its weight. This matter because in aviations every kilogram counts. A lighter engines that produce more thrust allow for higher payload capacity, better fuel efficiency, and faster acceleration. Brayton cycles helps jet engines to have few moving parts compared to piston engines, and the design is compact and use a shear compressor and turbine that are more efficient in extracting energy. The second one is continuous combustion ensure smoother operation. Unlike piston engine which fire in cycle, Brayton engine burns fuel continuously. This matters because the first one, steady thrust with less vibration. Uh, Second one, reduce mechanical stress on engine components. And the third one, increase reliability and smoothness of engine operations. And the fourth one is allow higher operating speeds and temperature. And the last one is efficient at high altitude and speed. Brayton cycle performs better as the aircraft flies higher and faster. This matters because the first one is commercial airlines fly at 30k to 40k feet where the air is thinner. Jet engines can compress this thin air efficiently and generate thrust without lose much performance. Turbines are designed to increase efficiency with higher Mach number. Jet engine can maintain or improve specific fuel consumption at high altitude due to reduced drag.